All right, let's get started with section 8.2 about proving triangles similar by angle-angle similarity theorem. So our objectives are to use the angle-angle similarity theorem in order to solve real-life problems. Our essential question, what can you conclude about two triangles when you know that the two pairs of corresponding angles are congruent? All right, let's start with our angle-angle similarity theorem. It states that if two angles of one triangle are congruent to two angles of another triangle, then the two triangles are similar to each other. Note in our diagram here, triangle ABC, so triangle A corresponds to angle D and are congruent by the same number of arc marks. Angle B corresponds to angle E and are congruent by the double arc marks. And that would be enough to prove that these two triangles are similar as long as there are at least two angles. You can have three pairs of corresponding angles, but at least minimum two angles. So if angle A is congruent to angle D and angle B is congruent to angle E, then triangle ABC is similar to triangle DEF. All right, so let's apply this angle-angle similarity theorem. Example 1, determine if the two triangles are similar. If they are, write a similarity statement and explain your reasoning. So note that we currently have two right triangles, so already we know at least one pair of corresponding angles are congruent. The other known angles are 26 and 64. They are not congruent, so we cannot conclude that the two triangles are similar so far. But what we can do is figure out the third angle of one or both of these triangles. Let's find the third angle of this triangle. We can say that angle C is congruent to angle K because they might correspond. So let's check the value. So if we subtract 64 from 90, that will give us 26 degrees. This gives us the second pair of corresponding angles that are congruent. This will be enough to conclude that triangle CDE is similar to triangle KJH by the angle-angle similarity theorem. All right, for example 2, I want you to try these. So try part A and part B. You want to show that two triangles are similar. So pause the video here and try part A and part B. All right, on our part A, we can conclude that triangle ABE is similar to triangle ACD by the angle-angle similarity. And that is one strategy, since the triangle ABE is inside of triangle ACD. You might want to separate them and label all the parts that are given. We see that angle B is congruent, or ABE is congruent to angle C, which is 52 degrees. And then they share the same angle, so by the reflexive property of congruence, angle A is congruent to angle A, which is enough. All you need is at least two angles. So we have two pairs of corresponding angles congruent, which is enough. For part B, they are similar by angle-angle. We can conclude that angle SVR is congruent to angle UVT because of vertical angles implies congruent angles. And then because we have two pairs of parallel sides, we have our alternate interior angles. So angle S is congruent to angle U. All we need is at least two pairs of corresponding angles congruent to conclude that by angle-angle similarity, our two triangles are similar. All right, and then our last example we'll look at together is a real-world example. We have a flagpole that casts a shadow that is 50 feet long. At the same time, a woman standing nearby who is 5 feet 4 inches tall casts a shadow that is 40 inches long. How tall is the flagpole to the nearest foot? Let's start by sketching the picture and labeling all of the parts. So here we have the 5'4" standing person, and then cast a shadow that is 40 inches long. And then we have our building or a flagpole, that we do not know how tall it is, that casts a 50-foot shadow. And because a person is standing perpendicular to the ground, it's a right angle. And because the flagpole is perpendicular to the ground, it is also a right angle. And because the shadow is cast from the same direction, in fact the sun, then we have corresponding angles that are congruent. Once you have your picture, it makes it a lot easier to set up your proportion. So we have x feet over 64 inches. Your 5 feet 4 inches had to get converted to all inches, so 5 feet times 12 would be 60, plus the 4 is 64. So that's where we got the 64 from. And then we have 50 feet over 40 inches for our second ratio. All right, so once you have your proportions set up, you can do your cross products, resulting in 40x equals 3,200. Divide both sides by 40, and x equals 80. Conclusion, the flagpole is 80 feet tall. All right, that's all for tonight's video. Bring your notes and any clarifying questions tomorrow to class, and we'll practice our angle-angle similarity together.